less than 10 seconds.
Hey everyone, Michael Unger here from the H.R. McMillan Space Center, here with our bonus interview for a virtual cosmic night, Mars. And we're here with Anna Mittelholz, who is a postdoctoral fellow in geophysics in the Department of Earth, Ocean, and Atmospheric Sciences at the University of British Columbia. And we're here to talk about Mars. We're here to talk about the Mars InSight lander. How are you, Anna?
I'm very good today. How are you?
I'm great. So let's get into you personally. And could you tell us a little bit about your research, your connection to the Mars InSight lander?
Sure. So I studied the magnetic field of Mars. And I came here as a graduate student to UBC. And that's really where I started looking into the magnetic field, mostly using satellite data back then. So the plan was initially that I would, as a PhD student, use InSight data, look at InSight data, but as you might know, InSight got delayed. It was supposed to launch in 2016. It ended up launching in 2018. That was actually quite nice for me because it gave me some time to, kind of get to know the planet from orbit. And I was lucky enough to got offered a postdoc position afterwards. And so I've been working with InSight data since we actually got it.
Oh,
right, and yeah, I guess this is my personal connection. What's nice actually about all of this, about me joining the team so early, I joined the InSight as a collaborator in 2013, is that I got to do a lot of the preparatory stuff, and if I got, to kind of think about questions like, what do we expect when we actually land? What do we think things are gonna look like? And then actually compare that with real observations. So that's been really cool.
Right. So, and of course, Mars InSight lander did land, which must have been very exciting. Was this like your first sort of like space mission when the lander did land?
Oh yes, that was my first mission, and the launch was really cool, and then the landing was even cooler. So that was all really exciting for me.
Awesome. Well, maybe you could just walk us through a little bit about like what InSight is, what it's doing, and how it works.
Sure. So InSight it's a lander, so it's stationary. It's not moving around on Mars, and really it has three big experiments, three big instruments, and the first one that most people really know is the seismometer. So seismometer is an instrument that measures basically ground movement. So what we do on Earth to measure earthquakes. And what the neat thing about a seismometer is that, so when an event, a seismic event happens, you can think about it as if waves travel through the interior of the planet on Earth, or for Mars in our case, and we measure these waves with our seismometer at the surface. But depending on what these waves travel through, they actually look slightly different. So they tell us about different characteristics of the underground, of the interior, in terms of composition and in terms of temperature. And well, fundamentally, they tell us what the planet is made of. And that is actually one of the big mission goals, to really get at what is Mars made of, and how did it end up the way it is today. And actually one more question, more basic maybe, is how seismically active is Mars at all? Because for the Earth, we have plate tectonics, we have volcanoes, so there's a lot more going on. So really, the first order question was, is anything happening on Mars at all? Is it shaking?
Yeah, so it's not really so much about like finding if there's going to be earthquakes. So of course, like there's not going to be, much damage to any buildings or people there, but really
right.
You're trying to find Mars quakes so that you can really understand more what's underneath the surface. Is that right?
That's right. Yeah, this is really the information that we're getting from these waves that travel through the interior.
Oh,
yeah, that's great.
So you had mentioned, so there's three instruments. So that the seismometer is there and it's been taking some of this data, but there's also a couple other instruments as well. What are those trying to look for?
Yeah, so the second big one is the heat flow probe, HB cubed, how they call it, and it's this little hammering mechanism that makes its way into the interior, or into the subsurface, and it has little temperature sensors. So it's trying to get at the heat that is coming from the interior. So that's the second big one, and the third one is RISE. It's basically antennas that track the position of Mars with very high accuracy. And what we can learn from that is we can basically see how much the rotation axis of Mars wobbles around. And so what that means, that there's oftentimes there's this comparison with an egg. So if you have an egg and you rotate it on a table, then depending on if the yolk, if the yellow of the egg is soft or if it's boiled, it will rotate slightly differently. So again, this is telling us something about the structure, about the interior, in this case, maybe the core of Mars. So that's sort of where this is getting at.
Right.
And
yeah, so I mean, and of course, this probe that you were talking about, I think that's been the one instrument of the three, unfortunately, that's gotten most of the news because it's been having some trouble getting into the soil. So could you maybe talk us a little bit through, like, why is it having trouble getting to the soil, and maybe a bit of an update on that?
Yeah, of course. So you're talking about the heat flow probe, the HP Cubed. So like I said, it's this little hammering mechanism. And well, it was supposed to go down at least 3 meters, or that would have been mission success, and it can go down 5 meters into the subsurface. And unfortunately, very early on, it got stuck. So what happened was that it was about, I don't know, 20 centimeters or something down, and then it just started kind of jumping up and down in the hole it had dug for itself. And while doing that, it was sort of increasing the diameter of the hole. So what happened is that it just lost friction from the walls. So instead of making downward progress, it was just jumping around. And that was actually in, I think, February 2019, so it was very early on. And since then, there have been several attempts to fix that problem, to make the probe go further. And basically, so the lander has this little arm with a scoop, and they've been trying to just kind of fill in soil into the hole, and also doing things like pressing on the soil to increase friction and to make the probe go further by itself.
Yeah.
So far, right now, it is basically flush with the soil, so it is somewhat covered, but it hasn't been making progress recently. So right now, there's again a group of people trying to think about what we're going to do next. And probably the next step is going to be to, instead of pressing at the soil from the side, what they did previously to increase friction, to press actually on top of the probe. So we'll see what happens with that.
I'm imagining, kids, maybe you were one of those kids that played in the sandboxes, and that's kind of what InSight is trying to do now.
Yes, exactly.
So
yeah.
What is this telling us about the Mars surface that we didn't know? Because obviously when they were planning this probe, they had some idea of what the surface might be like. So where are this coming from? Yeah,
so it's actually quite interesting because it's first of all, there was always the concern that we might hit a rock. However, the site where we landed, there are actually not many rocks, and we don't think we actually hit a rock. Also, the probe actually has the ability to sort of go around rocks if it hits one, or like push them aside or something. So we don't actually think this is the case. So this is really about soil properties right now. And I guess before we landed, what we thought we would find would be some sandy soil that we found at the Spirit or Opportunity landing sites. So the rovers that are operating or were operating on Mars. But turns out that the soil on Mars is just mechanically at the InSight landing site, is just mechanically slightly different. Also, actually, the pit that the probe built around the formation of the pit around the probe, or also the resistance it has to collapsing, is quite interesting. And there are actually a lot of people looking at that and kind of getting at the soil mechanics in this case.
Yeah.
So yeah, it's unfortunate, but also kind of interesting.
Well, this is the fascinating thing about science, and especially trying to do science from such a long ways away. Like here you are, we're on Earth, and you're sending commands to this rover so far away trying to figure out, and it's just trying to do a simple operation, trying to get into the soil.
Yeah, right.
But through these challenges, we are learning things. So could you maybe tell us about some of the things we are actually learning from InSight despite these challenges?
Yeah, sure. So, I mean, we have other instruments, luckily,
Yeah.
and well, first of all, of course, we have seismometer measuring actual quakes on Mars right now. So that's been really cool. We've been measuring many events that we think are of tectonic origin. So there's actually some movement going on that is not just because of impacts or something. So something that's coming from the outside, it's actually the planet. We've measured many small events, so there's a lot of weak movement, not so much that is strong. So that itself is actually quite interesting. And what we can do with that is we can, of course, look at things like the subsurface structure, and there's a lot of work going on right now to see, from what we record with the seismometer, how should the subsurface look like so that we record what we do, if that makes sense. So how can we match this data with a model of the subsurface?
Yeah.
And also actually, so something that I didn't mention earlier are a bunch of auxiliary instruments that we have also sitting at the surface. So we have these 3 main experiments, and then to make sure that we can actually do something with the data we measure, we added basically a big weather station to make sure that, something that the seismometer measures is not just wind or something that is caused by pressure variations or something. So we have a big weather station, and what is quite interesting to me, or what I find quite cool, is that we've actually been able to do a lot of science with this big weather station. And we were on Mars during a big dust storm, and actually it's a quite dusty season right now, and we're measuring all that on the surface, and with sampling rates with accuracy that haven't been achieved before. And also, as part of this auxiliary suite, and I think this is probably why I'm so excited about it, is there's a magnetometer. And again, it was added because we wanted to make sure that we understand space weather, and we understand if space weather affects any of our other measurements. But at the same time, it's the first magnetometer at the surface of Mars. So that itself has been really exciting. And the magnetic fields we measure, or the magnetized rock that we're sitting on, is actually much stronger than magnetized than what we expected from orbital measurements. So that's been really cool to see these first time measurements.
Yeah, well, let's get into some of that excitement that you have, because I'm curious. You're a postdoc fellow in geophysics in the Department of Earth, Ocean, and Atmospheric Sciences. There's nothing in there that says anything about space or Mars. So how did you come into working on this project? Like, did you have a passion about space? Like, did you, or even Mars? Where do your excitements come from?
So I think during my undergrad, I learned about InSight, and it was sort of because I read an article about it, and I thought this is really cool, and I want to work on that. So when I tried to find an advisor, I wanted to go abroad. So for me, it kind of made sense to go to Canada. And then I was specifically looking for someone who was a PI or a co-PI on that mission. And so that's how I found Catherine, and that's how I got to work on that. And it was the best decision I've made.
Catherine Johnson is amazing. She's been a speaker with us before. So before we leave you, Anna, we are asking everyone as part of our Cosmic Night event the seminal question. I know you've got your InSight t-shirt on. You're part of the mission. You're part of Mars. But if they were going to send people to Mars, scientists to Mars, would you go?
Absolutely. No, I'm actually planning on applying for the next astronaut selection in Europe, because I'm European, so that would be the one I would have to apply for. And yeah, definitely, I would go right away.
Awesome. It's so amazing, and hopefully they will have geophysicists on Mars one day, and maybe it will be you.
Yeah.
Everyone watching, thank you so much for joining this bonus feature for Virtual Cosmic Nights. See you next time.
Thank you.